Okay, so we have this French door refrigerator. Notice it says KitchenAid, Maytag, and Whirlpool because um, even though it's Maytag or Whirlpool, it's pretty much the same machine with basically some minor differences as well as cosmetic differences. When Whirlpool bought Maytag out years ago, they kept some of Maytag's ideas and wiring and components, but the old Maytag washer now is basically a Whirlpool washer, so they've changed up. So let's take a look at this French door refrigerator. I've screenshot some things out of the manual that I thought might be important. Reading about this, it says when you first install your refrigerator, make sure the temperature controls are still set to the recommended set points. The recommended set points are 37 and 0. So if customer plugs the refrigerator in, the controls are already preset to bring the refrigerator down to 37 degrees Fahrenheit and the freezer 0 degrees. And those settings can be adjusted and changed. And the instructions here tell you how to do it. I'm not going to go through all that today so I can cover more schematics. But I wanted to make sure that I had a full understanding of how this whole thing operates, because in order to troubleshoot, you need to know all the parts of the machine and how they operate. So that's a very important thing that you need to do. You can't just take a schematic and learn everything about the schematic and then go to the machine and you have no idea how the two of them go together. So this is just the controls and a preset. When you're checking the temperature, I have a company as well, and I have employees who they vary on how they check temperature. For example, some guys use the laser pointers. They're good and they're bad. When you open up the door, I tell them, when you open up the door of a refrigerator, think of the air inside the refrigerator as not air. Think of it as like water. If you filled up a container like that with water and opened up a door, that water would gush right out of the refrigerator if it was liquid. So air does the same thing. When you open up the door, the cold air goes flying out of the refrigerator and warm air is rushing in. So a lot of people like to use like those laser pointers and they shoot it at the back wall, but the back wall on some refrigerators is an air baffle. It's a channel that cold air from the freezer cools the fridge. So you're checking the air baffle and not actually the air temperature in the refrigerator. One of the best ways to get the actual temperature is if the customer has water or something in their refrigerator, is to actually pour a glass of water and check the temperature of the water, and that will give you the most accurate reading of what the temperature is in the fridge. So depending on how long you have the door open, if you put a digital meter with a thermistor wire on it and you stick the thermistor in there, again, once you open up the door, you let a lot of hot air in, you got to wait a few minutes for that unit to acclimate back to its normal temperature. What you see here in this picture is someone taking one of these pocket thermometers and putting them in ice water. That's a way to check to see if your pocket thermometer is actually calibrated correctly and reading correctly. Believe it or not, they do go off a little bit, and right underneath most of these there's a little nut that you can put an adjustable wrench on, and you can grab the outer rim of this with pliers and you can rotate it a little bit left or right to calibrate it. So the idea is to take a glass that I put more ice in this, and you fill it up to the top with as much ice as you possibly can. Then you fill it up with water to the rim, and you'll be almost 100% at 32 degrees. And at that point, you can calibrate your pocket thermometer to make sure it's accurate. So if you use one of these to check temperature in your box, which I had to do the other day, is I put it in there. If you don't let it sit in there long enough, it's not going to get the temperature of the fridge. It's going to take some time. So if you're doing a service call, one of these pocket thermometers are not going to give you the most fastest accurate reading that you're going to get. Now here, if you do need to make any adjustments on the temperatures, see it says if the refrigerator is too cold, you're going to actually raise the temperature up 1 degree. Refrigerator too warm, raise it low 1 degrees, and the same with the freezer, and that is the set temps that they put in there. If the set temp says 37 and you're getting 38 degrees, you can adjust the set temp 1 degree higher or lower to try to be more accurate. Again, if you do make any changes, usually you tell the customer at least wait 24 hours. It doesn't necessarily take that long to reach that temperature, but if you change the setting, remember, they got food and everything in there, so even if the air is 40 degrees in there, the food in there has not reached the temperature it was set at. So if you make any changes, the food, and depending on how thick the food is going to take time to achieve those temperatures. So this is how you calibrate your pocket thermometer, and this is the adjustment that goes with this temperature set points in here. And there is a way to go in and set it. I'm not going to go through those instructions today, but they are in that manual that I sent you. These are all, by the way, the text stuff is taken out of that service manual. Alright, the three-way valve. This is a dual evaporator system. I'm going to go back to that valve in a second. So we have an evaporator in the freezer, and then we have an evaporator in the refrigerator compartment. That's the way they are able to be more precise in the temperatures that they set those compartments at, where they can run the freezer till it reaches temperature and then run the refrigerator. Right here, I'm going to go back to it, this is called a three-way valve. This valve sends Freon to one or the other evaporator, but the third position is the valve is completely closed. Let's take a look at this for a second now. So here's a valve, and I'm going to zoom in on it real quick so you can see it a little better. This is your three-way valve right here. This comes off of your condenser, and it has a dryer filter in front of it, which is running on this line right here that says dryer filter. I'll go ahead and just trace it with the yellow marker. It runs up here and it runs into your three-way valve. So this valve here is the control of which evaporator gets its Freon. Now we have two outputs. We have one here, which is going to one of the evaporators, and then we have another one here going to another evaporator. These are actually capillary tubes, and those capillary tubes go to the evaporators in the refrigerator and the freezer. So if we look at the information here, let me resize it back. The refrigeration system is called sequential dual evaporator system. There's two coils, two capillary tubes. There's one in the freezer or fridge. Three-way valve is used to direct refrigerant flow to either evaporator. Now, it's only directed through one evaporator at a time. So when a customer first plugs the refrigerator in and it's completely warm, or if you do service like change a compressor or something like that, it's only going to energize one of the evaporators in the system. Now, here's the back of the refrigerator. This is an inverted compressor. We have a separate inverter board here which controls it. We have two mufflers, and again, let me bring that to the front here. So these are called mufflers. They're not your dryer filter, which is over here on your right hand side here. This is your dryer filter. These two devices here are called mufflers, and those devices are mainly for sound. When refrigerant flows, I know some Frigidaire units had some of that like gurgling noise that would come into the evaporator as Freon entered. The mufflers there help reduce the sound of the refrigerant flowing through the system. They are not dryer filters, so when you do a sealed system job, you don't have to replace them. The dryer filter you do, but not necessarily the mufflers. So make a note how the mufflers look, that they're a little bit bigger around than the dryer filters. Okay, the dryer filter comes from your hot gas loop or your Yoder loop, depending on your manufacturer, and the condenser's underneath here, and the refrigerant goes into your three-way valve here. So that's the refrigerant flow. uh, and components that you need to be aware of. Now again, forgive me if I'm going a little fast because I want to get to the actual schematic, but I wanted to point some things out so when I say something about a specific part, you guys know what parts I'm talking about. If you have any questions, just, go ahead and ask them. Okay, so the refrigerant check valve is used to isolate evaporators and prevent refrigerant flow back into the evaporator. So you see this thing that says check valve and it's pointing right here. This is the suction line to one of the evaporators, okay? And what a check valve does, it's like the door of your house. Either the door of your house opens to the outside or it opens inside, but it doesn't swing both ways. So if your door opens to the inside of the house, for example, if you're trying to go to the door and run out the house, the door doesn't open that way, it would prevent you from going out the door. Check valves do the same thing. They let refrigerant go back to the compressor, but they don't let refrigerant go to the evaporator. And the reason that is that the two of these evaporators go to one suction line on the compressor. Okay, you see this muffler here? Let me see. This muffler here, let me make it a little bit smaller. This muffler here meets the other muffler here and goes into the compressor here. So I said that both evaporators don't run at the same time. So how do you prevent freon that's coming out of one evaporator and prevent it from going back into the other evaporator? Let's just say the compressor is sucking freon and the check valve has this evaporator and the freon's coming from the evaporator going into the compressor in this direction. How do you keep it from flowing back to the other evaporator? With this check valve. And what's so important about a check valve? Does anybody have any ideas why a check valve is very important to have? Okay. Check valve prevents it from flooding the other evaporator, and it's going to affect your pressures. It'll lower your evaporator pressure, because if I'm sending freon to one evaporator and some of that refrigerant is able to go back to the other evaporator, now I've just made it like a bigger evaporator. So what happens is it actually lowers your pressure and it causes insufficient cooling. And the other part about the check valve is when you are checking the system for leaks after you do service, one of the things you would do is you would have a access valve here on your process stub, and you would go ahead and you would put nitrogen in here, and you would put nitrogen at about 100 psi. And normally we'd only go about 100 psi because the evaporators are made out of aluminum, and if you put too much pressure you could damage the evaporators. I've had people make a mistake and put the low side on the discharge line and the high side on the suction, and they were charging the unit up, and as they were adding freon, all of a sudden you heard pow, and they blew out the evaporator inside the refrigerator. Excuse me, evaporator inside the refrigerator. But now with these check valves, which you'll only find on a dual evaporator system, you cannot put too much nitrogen in the system, because if you overcharge it, you could damage the check valve in the system, and that could completely restrict an evaporator. So one evaporator may not get freon. Just imagine jamming the door shut on your house. You can't get out anymore. So it looks like this check valve might be external, which is good. I think LG has a check valve, but it's inside the wall. And if you damage that check valve, that refrigerator is not serviceable on that check valve. You basically just, restricted an evaporator that it will never cool again. So it's important to know not to put too much pressure inside of a system. All you want to do is to have enough pressure that if any of your braze joints are leaking, you could put soap bubbles on your braze joints here and see if any of these braze joints on the unit may be leaking. Okay, So you put 100 psi and you hold it at 100 and see if the pressure drops. And at the same time, you just look at all the braze joints that you just finished brazing, put a little bit of soap leak detector on there, and see if you have any leaks coming out of that system. So let's talk about cooling operation. When you first plug in and the cabinet is warm, the three-way valve moves to the closed position. So pay attention. So when we first turn it on, we have two evaporators. But this valve completely closes off and the compressor is sucking the Freon out of the evaporators and pumping it into your condenser down here on the bottom. So there is no Freon going to the refrigerator or freezer compartment when you first turn it on. Okay, so it does something we call a pump down. Central air conditioning technicians do that when they want to take the coil out of the house and clean that coil. They close off a valve and the compressor pumps everything into the condenser. So this unit does a pull down. So with the three-way valve still in the closed position, the compressor evacuates the refrigerant from the low side system and pumps it into the high side of the system. So we're pumping everything into the condenser. So approximately 2 minutes into that pump down, the valve changes position, allow refrigerant to flow from the high side into the refrigerator evaporator. Now this is important. So that means the refrigerator compartment is going to cool down before the freezer compartment. So when you first plug this refrigerator in for 2 minutes, you're not going to have any cooling on either compartment. So if you did a sealed system job and you charge this refrigerator up with Freon and you're letting it run, you say, well, let me see if it's cooling. And you go to the freezer and you put your hand by the fan and there's no cold air coming out. And you go to the fridge and you're like, oh man, I have a restriction. Remember, we have this closed valve here for the first 2 minutes. And 2 minutes don't sound like long when you're talking, but when you're sitting there waiting 2 minutes, how many times you put something in the microwave and took it out when there's 3 seconds left because you couldn't wait 2 minutes? So 2 minutes is a long time. So then it's going to go into the refrigerator compartment. At that time, you can open up the refrigerator door and check the airflow coming out the back of the refrigerator and see if the air is cooling and starting to drop. So when you do a pump down, what's going to happen to your low side pressure on your evaporator? You got a valve here on the low side, and some of these dryer filters have a valve on the high side, so you got your gauges connected. Let me just, I'm not going to be the best in drawing here, but you got your gauges. You got your low side and your high side. And the low side is connected to here, and your high side is connected to here. When you first start charging the unit, what kind of pressures are you going to see? Anybody have any idea what kind of pressures are gonna be evident when you first start charging this unit up?
Low pressure's negative.
Yeah, the low pressure is going to pull into what we call a vacuum. So right here on the low side, it's going to be about 0 psi. And if it's a 134A unit, we're going to run normally at about 0. But if it's a R600A, the pressure is a little bit higher. So it's going to be below 0, but your high side pressure is also going to go up until the condenser fills up. So you're going to have a higher than normal high side, and you're going to have a vacuum on the low side for the first 2 minutes. Don't get distracted as you're charging the unit and say, oh, I have a restriction. I keep adding Freon and it keeps pulling into a vacuum. Remember, when you first plug this in, you got to wait 2 minutes before the three-way valve is going to open up and let Freon go to the evaporator. So after that happens, that refrigerator is going to cool down the refrigerator compartment and drop it to the right temperature. After that temperature is reached, or after 20 minutes, the three-way valve changes position from cooling the refrigerator to cooling the freezer. So look at that. If you let it run, it's going to take 20 minutes before the freezer ever starts to cool down. Now we can circumvent this, and we could see that both evaporators are working and no restrictions are evident by going into diagnostics and forcing that three-way valve into different positions. I'm not going to go over that today, but we'll discuss that in another class. So please be aware, if you're working on something like this on a Whirlpool unit, a lot of these newer Whirlpool units will pull down into a vacuum when you're starting to charge them. That is normal. So cooling of the freezer compartment continues for 15 minutes and then switches back to the refrigerator, and this will go back and forth until both the refrigerator and freezer reach that set point that I pointed out at the beginning of this class. Now, in normal cooling, if the refrigerator compartment is calling for cooling, the control determines if the refrigerator evaporator coil temperature has been above the predetermined temperature. So they're seeing if the evaporator is 35 degrees Fahrenheit. This to assure the evaporator coil is defrosted. I do not see any defrost heater in the circuit for the refrigerator evaporator. The refrigerator evaporator is what they call cycle defrost. And we'll look at the schematic and point it out. But what happens is, if this temperature goes over 35 degrees Fahrenheit and maintains that temperature for 15 minutes, it's going to assume that the evaporator is not frozen. How does it know the temperature of this evaporator at 35 degrees?
Thermistors?
Yeah, which thermistor would we be looking for to identify that? Let me see if I can.
Go ahead.
I zoomed in now. I might give you a little hint.
Refrigerator thermistor.
I got two thermistors on there. Can you be more specific as to which two, which one it would be? If you don't know, it's okay, but...
Nah, you got me.
Okay, well, RC stands for the refrigerator compartment. So a thermistor, if you don't know what a thermistor is, some people are not familiar with it. A thermistor is a resistor, and that's what this jagged symbol is. And the arrow at a 45-degree angle means it's adjustable, or it might change value. And what thermistors do is they change resistance based on the temperature. So if the temperature goes lower, the resistance might go higher. Or if the temperature goes higher, the resistance might go lower. We call that an NTC thermistor. Negative temperature coefficient. I'll write them down. Well, I can't write them on this screen. But NTC is usually used on products that do cooling. PTC, which is positive temperature coefficient, are usually used like in heating products like your oven or your dryer or something like that. But going back to the question I asked, and to answer your question, RC means the refrigerator compartment, but notice we have two RCs. One is refrigerator compartment thermistor, and the other one is refrigerator compartment evap thermistor. So this one here is inside the refrigerator, and it's located where the customer's milk and their food is in the refrigerator. Its job is to tell the unit, the control board, hey, the inside of the refrigerator is 34 degrees, go ahead and shut off. The evap thermistor is used for multiple things, but this one here is actually on the evaporator. I'm going to see if I can find it in the service manual here. Let me just rotate it back. Well, there's 34 evaporators in here, so okay. That's just temperatures, the evaporator. So service test 3 is to, now it's the fan motor. Let me find that. Okay, so this particular unit here has the baffle that I was telling you about, and on some of the units the baffle is the storage for that thermistor. I'm trying to find out if they identify the thermistor in these pictures here so I can show you exactly where it is. So this is the evaporator thermistor. This is the thermistor that's located on the evaporator, and I'll zoom in on it so you can see it. That's this little gold colored piece or copper colored piece with these black wires on it, and they're clipped on to the suction line. Now if anybody's familiar with a regular refrigerator with a regular timer and defrost heater and defrost bimetal, the defrost bimetal or defrost thermostat is always located on the suction line, which is the larger of the two lines. So this thermistor here is attached to the suction line, and this is also the one that's used for defrost. This one tells the control board the temperature of the line and not necessarily the temperature of the air that's in the box. Now let me see if I can find the refrigerator thermistor. It might be with the damper, so I'm trying to find it. Oh, there it is right there. So here is the refrigerator thermistor, and don't let this confuse you. This is for the bottom one, and this is the refrigerator compartment evap thermistor, and they're showing it to you again down here. Refrigerator compartment defrost thermistor. You can see a little bit better how it's clipped onto the tubing, but this is the refrigerator compartment thermistor. This is the one, it's attached probably to the side wall of the refrigerator. They're not showing exactly where they unclipped this, but this is the one that's in here. I know that GE had a lot of problem with some of their thermistors failing, and the wires went into the wall, and you'd had to cut and wire nut them, and they didn't give you much room to connect those wires in that little space. But this one here is showing you the wiring goes into this quick disconnect here. Yes, Rudy.
So when you say the wall, you mean like the inside of the fridge? Or?
Yeah, on GE's, you have a thermistor just like this behind a cover, but these wires are going into like this white wall here on the right hand side, and there's no quick disconnect to unplug it. You probably have about 2 inches of wire, so the trick is to cut it right at the thermistor so you have enough wire to connect to your replacement thermistor. The nice thing about the GE thermistors, and I don't know about the Whirlpool, but they look different because the wiring looks different, and it looks like these are connected to one quick disconnect plug. So if one thermistor fails, it looks like you're going to be replacing all of them unless they tell you to cut and wire nut them in. But the GE thermistors are all pretty much the same as far as the part. So you could carry one GE thermistor on your truck, and it may work for 90% of the refrigerators you have if you have a faulty thermistor. So this one is checking the air temperature, and this one is checking the refrigerator tubing. This is for defrost, and this is for checking the compartment temperature inside the box. So depending on the problem you have, you need to know which thermistor is the one that you need to test. So if the evaporator coil is above the predetermined temperature but for less than 15 minutes, the refrigerator fan turns on to circulate air over the evaporator coil to defrost it. So in other words, we don't use a defrost heater like most refrigerators. I think Sub-Zero has an evaporator in the back of their side-by-side units that does not have a defrost heater. So the thing is that when Freon stops flowing through that tubing, the refrigerator is so warm that ice will just naturally melt off, and if we turn the fan on, we pull that air over the coil to help speed up that melting process. It still has a drain pan in the bottom of the fridge, and there is a drain trowel that runs the water down in it, but you have to know that there is no defrost heater. If you see a frozen evaporator and there's no defrost heater, there's got to be another way they melt that ice. In the Samsung Family Hub refrigerator, I did a video where we melted the ice off the evaporator, and then I did a second video how we troubleshoot why did that evaporator frost up. Those videos are in the free member section. But that refrigerator was similar to this one. The evaporator had no defrost heater, no defrost thermostat on the unit at all. It just cycled off and defrosted on its own. So these are just the noise filters. I pointed them out already, just a close-up view of them. I'm not going to talk much about them. And here's the schematic. I got a blown-up version. I just put it on there. Let's take a look at the power supply board. The power supply board is located above the main control board, so we got two boards here. Power supply board gets the power from the wall, and it feeds everything inside the refrigerator through its output of the power supply. There's a transformer right here, that's what this yellow thing is, that will step down the voltage. If you look here, on plug number 1, which is this plug here on the left hand side, pin 1, 1 and 1, 2. So if you look at this number 1 here in the black box there, that points out that that is the first wire on that plug. So this white one down below would be the second wire. This wire that's white with a stripe on it is the third wire. And this black wire with a white stripe on it is the fourth wire. So if you look, P1 is indicating plug number 1, and they also state it here, P11 and P12, which is the first and the second wire, should have 115 volts all the time. Now if we look at P13 and P14, that also says 115 volts. Let's go to the schematic and take a look at that, and then we'll come back and look at what the other connector does. So I have the schematic, here, and let's go back to that schematic. I think it was further down. Nope. Here we go. And let's rotate this so it's easier to see. And I lost my, where's my diagram? Okay, let's rotate this and then I'll zoom in so you guys can see it. Something happened. Let me refresh it. I lost my manual. Sorry guys. Okay, here's the schematic. So now it's upright. So let's take a look at this unit, zoom in, and what I want to find is the power cord on this unit. So let me see here where they put the cord on this unit. Right here to the left. So I'll zoom in even more so you guys can see it. Black is smooth, black rib. So the power cord is blacked. The smooth and the rib, the smooth is line 1 and the black is actually neutral. Don't get confused by them putting L2 on here. The ribbed, if you ever looked at a power cord, they either put a dashed or striped line on it to indicate the neutral, or they actually have ridges on the power cord. So if we follow this in, this cord goes to a plug here. The first thing that plug is going to do is going to go to our power supply board. Now this diagram is a little hard to follow, so let's find that power supply and say, well, how do you know looking at this that it goes to that? So let me find the power supply board. That's the Aurora board. That's the Stealth. I can find the power supply here. I don't see that board. Give me 1 second to find the input of that board. They're not showing it directly on this unit. I'm going to bring up a different schematic, the one that we have on the screen here. Give me a second here. This one's a little bit easier to identify. Right here. This PS board is the power supply board. So if I zoom out for a second, I can show you that our power cord is line 1 and neutral here. Let me make it full screen. Our power cord is line 1 and neutral here. If we follow line 1, it runs right into this board right here on plug 1, pin number 1. So we call that P11. And you can see that the other blacks go to the inverter board, which is on the compressor. So on the compressor we have 120 volts all the time. We got a black wire going to a smart filter switch, and it means if the customer takes the filter out, that switch will let the machine know, hey, don't allow them to get water or ice without that switch being closed. This is light switches here, and then you have your power supply board. So line 1 and neutral go into the board here. Then line 1 and neutral here, if we follow that line out, and I'll zoom out to show you, they come into the main board on P11 and 12. So let's take a look at that here. So if we look here, and I'm going to copy this and then bring it into a tool I can draw it. I'm just going to paste it right over this, and then I'll zoom out. So if we look at this schematic here, line 1 comes in through this diagram here and goes into this board on plug 1. My drawing is horrible. Fix that, sorry. It comes into the board here. Neutral comes back out and goes to the power cord. Now these two, if we follow them, and I'm just going to put a dashed line on these two so you can see them, they run into the main board on plug number 1. Now the reason why that's important is I want to show it to you in the pictures of the actual boards. So P1 here is P1 on the power supply board. Okay? Now, the other P1 is on this main board. Now I have a picture here of the main board. This is the bottom board, and this plug here on the upper left hand side is P11. So this black with white stripe and this white right here is power going into your main board. So if we go back to the schematic, this right here is this black and white wire right here. And I'm going to zoom out, let me put it in the front. So power from the wall comes in and goes into this board. Then power comes out these two wires and they run down here and go into the board here. So this is putting 110 volts to our main control board right here. Okay? So this is input into the board. So if you had 110 volts here, you want to see if you're getting 110 volts here if nothing is operating, to make sure that your main board is getting power. Anybody got any questions so far? Okay. Let's go back to the schematic. So that's input voltage. Now we have another plug, P2, which feeds the rest of the components on the board. And if we look at this, I'm going to bring this to the front now. P2 has 4 wires here, and well, actually 6 wires, and pin 1 and pin 4 is 14 volts, 2 and 5 is 14 volts, 3 and 6 is 14 volts. Those are the voltages that are going to like our fan motors and other low voltage components, as well as that is coming off the main board, which is our communication wire for our compressor. If we look at this schematic here, we have 120 volts, line 1 and neutral, on these two wires all the time. But we have two more wires here, and if we follow them down, I'll use a different color. If we follow them down, I don't know if I got the full diagram here or not. No, I have to use the other diagram. Hold on one second. If we follow these two wires down, all the way down, they go into your board on plug number 8. I'm going to zoom in on that so you guys can see it. So these two wires on the inverter are coming down here, and they're running over here to this blue and brown wire. The top one's blue and the bottom one's brown. So if I was following this over, notice how this crosses over. The blue one's here. This wire right here is blue and this is brown. So if your compressor didn't work, there's two things you need to check to see if that compressor and inverter board is working. One, we want to check 120 volts coming into the inverter. The customer does not have to turn the refrigerator on. The control board could be off and say, I don't want cooling. But the inverter board is connected to power all the time. So if you have an inverted compressor and you want to know if this refrigerator has got a bad compressor or bad inverter board or bad main board, the first thing you want to know is make sure you have proper power to the inverter, 120 here. Now you want to check the communication voltage here, which is on pin 7 and 8. This is one of those plugs that'll probably be running 12 to 14 volts, and when the refrigerator's calling for cooling, these two wires basically are the one telling the inverter, hey, turn the compressor on. Now those voltages are usually DC voltages. If we go back to the presentation here and we look at this here, we have AC voltage coming in and AC coming out, but we also, not only do we lower the voltage from 115 to 14, we're converting it to 14 volts DC. So the output on this plug is DC voltage. So if we go back to the schematic here, the voltage going to the inverter board on those smaller wires are going to be DC. So you have to check for 120 coming in, and you have to check for DC voltage coming in. If I have DC voltage on that plug, and let's go back to the schematic. If I go to the refrigerator and I say, hey, my fridge is not cooling, and I'll use this diagram right here. I got my red and black here coming in, and then I got my 110 volts coming in on these two plugs. I got 120 here, and let's say I got 12 volts DC right here. Is my main control board good or bad?
It's good.
It's good because it's sending the signal to the inverter to tell the unit to run. Now, sometimes you can check the output voltage of the inverter, but since they're variable capacity compressors, which means they run at different speeds, they send voltage to the compressor, different voltages. You're not always going to have the same voltage. The only way you're going to have the maximum voltage is by going into diagnostics and forcing the compressor to run through the diagnostic test of the compressor to get the max voltage here, because when you go into diagnostics, it tells to the compressor to run as fast as it can. So you're going to have the maximum voltage. I think it's 270 volts DC. I'm not 100% positive. I have to read on that, which I will get that information for you guys. I'm not going to take the time to look for it now. But if I have that voltage there, one last thing I want to do is I want to ohm out my compressor. Now the drawing doesn't show it too well, but if you look, and I'll zoom in, it shows 3 windings, but only 2 wires. I don't think it has 2 wires connected to the compressor. It probably has 3. The only ones that have 2 wires going to the compressor that I know of are LG, and those are those linear compressors. But this one has 3 windings, and if you look at the compressor, you'll find 3 pins, like just a normal compressor. What you want to do is ohm it out that all 3 pins should give you the same resistance value. I had guys testing a compressor out on a refrigerator last night, and all 3 tests gave you 8 ohms as an example. Now, you sent me that service pointer for the frozen evap. Could you tell me what that was? Someone sent me this service pointer. I'm going to just bring it up. So this is French door refrigerators, frost buildup on the evaporator. Placement described as pointer specific to models as well. It is possible that some consumers may experience frost or hard ice and forming on the front area of the refrigerator compartment evaporator. Customers may also have water pool and evaporator drain issues leading to a no cool. So order this service kit. I have not seen this yet, but let me see something. I'm just reading it here. So they're one of the things they want to say is they want to make sure that this thermistor is accurately reading the temperature of the line. If it's loose, it's going to check the temperature of the air. So what you see in the picture of the pliers is the guy squeezing the clip for the evaporator so it fits tightly, and then a zip tie that holds it to the suction line. All right. 0 to 1/4 inch to the right of the ridge. So not only is it the suction line, but it's an exact placement that they want you to put it. If it's on top of that ridge, what do you think would happen if that thermistor was like right here in between where this ridge was? Anybody have any idea? It would not accurately read.
It wouldn't have good contact with the
line.
Yeah.
Yeah, if it was on top of this ridge, only part of it would be touching the metal and won't accurately read the temperature. So this is my first time looking at this unit. So I guess they're also having problems with the drain pan leaking or freezing up, and they give you some silicone to seal up to prevent it from leaking. So the evaporator fin should sit about 1/4 inch back from the enclosure. I don't know what fins those are. I have to look at it. Did someone got a question?
I came in late, Rich. Is this a GE monogram?
No, this is the Whirlpool refrigerator.
Whirlpool? Oh, all right, my bad. Okay, thanks.
Yeah, I sent out the schematic and the service manual, but I did say that the manual that I did send is not exactly the one that I sent the schematic for. I didn't realize that till I got to the defrost circuit, which I'm going to go over now. Now, normally my class is going to go till 1, but I will go a little bit over today. So let's go back to the schematic. So these are all the pin locations and plugs. They are identifying pin 1 on each one of them. Okay, that's important to know because when you're looking at those test sequences here, they're telling you from and to. This is where you're going to put your 2 meter leads to check for 115 volts. Plug number 1, pin 1, and plug number 1, pin 2 So you're going to be on pin 1 and pin 2, this black and white one here. So I had a defrost circuit here. And like I said, I downloaded the diagram based on the model number, and while I had that open on Service Matters, I saw Service Manual and I downloaded it, and I didn't look at the front of the manual. Now if we look, the front of the manual, I'll go back to that diagram in a second, had all the model numbers on there, but this didn't have that model number. So I downloaded it now, but going back to this diagram, I'm like, okay, let's start talking about the circuits and how to test them and everything else. And I'm looking at this test on plug number 2, which is the main control board next to where the power comes in. You're going to check plug number 2, pin 3, and plug number 1, pin 2. So they want you to use the neutral off this plug, because if you look at the defrost heater, it runs over here to neutral. But it also is on the main board here. And then plug number 2, pin 3, will be the third wire here. If this is pin 1, 1, 2, 3, it's that wire right there. It's a little bit hard to see. Let's see if I can zoom in a little bit on it. I think that's a purple colored wire. And I'm like, oh, okay. But if you look at it, there's a problem. The problem with this is it says heater bimetal bypass service test number 6. So if you're going to diagnostic to check that component, you want to test, you go into test number 6. But first of all, I'm sitting there looking at this and I'm saying bimetal, and I'm looking at the defrost heater and I see 2 thermal fuses. I don't see a bimetal. And I'm like, okay, that's odd. So then I went a little bit farther and I said, wait a minute. Plug number 2, pin 3, if we look at plug number 2, pin 3, that's a red and white wire, right? If I look at plug number 2, pin 3 here, and I go plug number 2, this is plug number 2, pin 1, 2, 3, that's not a red and white wire. And if we look here, if we look at the defrost heater, it goes to pin number 7 here. And it's a pink wire. Well, pink is the 7th wire here, but that's not what the instructions say to test. They're saying to check a bimetal. So that's what threw me off. I'm like, where's the bimetal? So let's take a look at these 2 circuits. I screenshot both of them. And this one has 2 thermal fuses, and here's the defrost circuit here. Through this thermal fuse, defrost heater, and this thermal fuse to neutral. But this one goes through a defrost bimetal, defrost heater to neutral. And if I wanted to check the bimetal, yes, I can check from brown, pin 3, to pin 7, or I can go pin 3 to the neutral on the main board, or I can go pin 7 to pin 3 to check this bimetal. Now, one thing bad about this, the way they put these thermal fuses, there's no way to isolate them. You can ohm out the heater from the board, but if you get no reading, it doesn't mean the heater's bad. You could have a bad thermal fuse. And those are probably in the harness. They're not a fuse that you can just replace the fuse. So you'd have to probably order the harness with the fuses in it. But look at this bimetal here. Let me put this in the front. If we look at this bimetal, what's going on inside this bimetal? Why does it have another part inside of, this is the actual bimetal, the switch that opens and closes to turn the heater off if it's too hot. But what is this underneath and why is it there?
It's like a resistor.
It is a resistor. So if you wanted to check the bimetal and you check pin 3 and pin 7, if the bimetal's open, you're going to get a reading of the resistor. And that's, I don't remember what the resistance value was. Maytag had it inside of all their thermostats for years. But you'll get the reading of the resistor. If the bimetal's closed, if this switch here is closed, and you check between pin 3 and pin 7, you're going to get 0 ohms. So if you want to know if the bimetal's good, you can ohm it out. If you get 0, you know the contacts are closed. If the box is not cold enough, you're going to get a reading of this bimetal resistor here. So on old style Whirlpools that had no electronic control, they had a bypass where you could run a jumper wire, because, and I'll tell you what the jumper wire is for a second. When you go into defrost, the board sends power to pin 7, it runs through the bimetal and goes through the heater. This pin 3, all it is there is for the board to know when this bimetal opens up, and the back of that unit, remember this is the freezer because the refrigerator don't have a heater, it knows when the bimetal opens back up and we can stop heating back there. Because back in the day we had a mechanical timer, 22 minutes, we defrosted. If it defrosted in 10 minutes, it still ran that heater till the bimetal opened, and the timer still stayed in defrost until the refrigerator timer timed out at 22 minutes. But in the sake of saving energy, this pin 3 is only there to watch the bimetal if it opens, so it knows from 0 ohms to the high resistance, or it probably checks voltage and sees a drop in voltage, and it knows, okay, the defrost bimetal opened, the back of that freezer's got to be warm enough, we can stop defrosting and go back into cooling. But as a technician, the brown and pink wire on the old mechanical ones had a plug. They had, you would, let me just see if I can find it, because I think it's very interesting. Where was that schematic I just had open? Here. No, here. Let me just, I'm going to search on another screen. 1 second. So they had a plug. If you opened up an old school refrigerator and you opened up the plug or the control panel, you're going to see a plug there with a brown and pink wire on it, and it's not connected to anything. I don't see it here. I thought I could find it if I did a Google search. Someone might have posted a picture of it. I'll post a picture of it and send it to everyone. But anyways, the bimetal bypass allowed a technician to run a jumper wire from pin 3 to pin 7. So when they energize the defrost, if this is not working, let's say, this bimetal is going to be on that suction line of the evaporator. You're like, man, it hasn't defrosted for 2 or 3 weeks. I got to get back there, and that thing's frozen solid with ice. So then you said, okay, I'll put the unit into defrost through diagnostics, but if the bimetal's bad, the heater ain't going to work. So if you run a jumper wire from pin 3 and pin 7, brown and pink, it will bypass the bimetal and send power to the heater, so the heater can melt the ice back there while you add heat in the front, trying to melt it down so you can get that panel off for service. So the brown and pink was always on Whirlpool refrigerators for as long as I know. Oh, I did find something here, but not the brown and pink wire. But that's what that's for. You can ohm out the bimetal and you can test it. So let's say the unit's not defrosting. One, you want to go pin 7 and neutral on the board, which is pin 2, and you want to see you got 120 when you're in defrost. If you have 120, you know your board's good. If you don't have 120 coming in here and here, your board may have a problem. If you have 120 and we don't have heat, next thing you want to do is check your bimetal. Is your bimetal closed? Now, what if your bimetal gave you 0 ohms? Well, the only thing left is your defrost heater is bad. But can we ohm out our heater? And if we do, where would we ohm it out at? Anybody got any ideas? I want to check this heater for ohms.
Yeah, I can see maybe pin 3, but I don't see where it goes to.
Well,
pin.
if we look right on the edge of my screen, what color wire is that?
Is that white?
Yes, sir. So I can use neutral on plug number 2. So I put a meter lead here, and I put a meter lead on pin 3, and that'll run bypassing my bimetal right through the heater, and this neutral goes back to the refrigerator. I don't have it right here, but through that power supply board, it goes back to neutral. So I can ohm out that defrost heater. I can ohm out this bimetal. I can check for voltage coming out, pin 7 and pin 2. So I can do all that testing just from these 3 points on the board. And I tell you what I'll do, just for the heck of it, I'll make up a little cheat sheet on this particular schematic. If you check this plug and this plug, and I'll highlight it for you, this is what you're testing and this is what you're looking for. If you check from this plug to this plug, these are the different tests you can make. If you run a jumper from this plug to this plug, you can bypass the bimetal and force the heater to operate even if the bimetal is bad. So those are the things I wanted to cover. I think that's all that I have prepared for today because we only have an hour. We might extend some of our classes a little bit depending on the content that we're talking. But anybody got any questions on some of the stuff that we went over?
Nah, all good stuff, Richard. Thanks.
Okay, and this other one here with the thermal fuse, we can also check pin 7 to pin 2 on this one, but we cannot separate the fuses from the heater. So either we're going to get the resistance value of the heater or we're not going to get any reading at all. That one here is going to go through here and back to the power supply board. It's going to go back to this white one here. I can ohm the defrost heater from the board, but if I don't get a reading, I don't know if it's the thermal fuse or the heater that's bad. One of those 3 are bad. So that's the only thing on that one. So the schematic we have, I think, is the one with the thermal fuses based on the model number, but the manual that I had was the one based on the bottom. So I wanted to point them out that they're 2 different schematics. They both do the same thing. Notice that they both use pin 7. They both use a pink wire for defrost. One thing that I really liked what Whirlpool has done, and this goes back to the old belt drive Whirlpool washer and the old refrigerator. One thing that Whirlpool was very consistent in is when they went from the belt drive to the direct drive washer, and then they went to other washers, they kept the color codes the same in the wiring diagram. And they're doing the same thing on their electronic controlled refrigerators versus their mechanic controlled refrigerators. Pink is always defrost. Pink and brown was always to test the bimetal. Brown always went to the defrost heater. Now they don't have brown here, but pink is defrost. If you look at any Whirlpool timer, pink is your defrost. So that's it for today. Again, we will post up and let you guys know once the calendar is updated. Tomorrow, by tomorrow, I'll have this video uploaded to the member section. And last class that I did is also uploaded in the member section. I put a date, like new videos as of this date. So we got to figure out a way that we can try to like organize them so you guys can know if you missed a class, where do I go to look for them. So that's in the paid member section on the class videos, and you guys are welcome to go there and check them out, and this video will be uploaded then. So if anybody else doesn't have any questions, then I appreciate you all for coming in tonight.
Have a good weekend, Rich.
You too now. You take care.